Hi everyone, today we are going to be looking at the reflection of light experiment. For this experiment we need a ray box or light source. Here we've got a red laser and we need a mirrored surface. So my surface is mirrored just on one side. It is a plastic block which makes it a bit easier for me to manoeuvre. Now I want the mirrored surface to be at the top here. So I'm going to position it just on my page in a straight line, and I'm going to draw a line where that mirror should be placed, just so that we've got it back at the same point if we remove it. Now the first thing I'm going to do is I'm going to remove the mirror and I'm going to pass the laser light through this line somewhere right in the middle. Now what we notice about the light is that it travels down towards the line and then passes on in a continuous straight line. It does spread out slightly just because it's a laser light, but it does continue down in the same straight direction. Now if we take our mirrored surface and we pop that back on the line, something happens, and this is what we're interested in learning about today. What happens is that light that once travelled all the way through is now bounced off of the mirror and it's continued off in a new direction. I'm just going to close it blind a little bit more so you can see it more clearly. So as it's hit the mirrored surface just at this point here, it has continued on in a new direction. No matter what angle you hit the surface, as long as it hits a mirrored surface, it will reflect off of that surface. So let's position it where we had it to begin with, just a bit closer. And what I'm going to do is I'm going to try and draw the red light line so that we can look at it a bit further. So using my protractor's straight edge, I'm just going to follow along where that light is as best I can. And then I'm going to do the same for the reflected ray. Now what I'm going to do is I'm going to remove my equipment and have a look at my result. So this line here is where we placed our mirror. So this is our mirrored surface. This line here is where we had the light coming in. So this is known as our incident ray. That comes towards the mirror. This line here is the one that comes away from the mirror, so that's known as our reflected ray. Now, to find out the interesting thing about reflection, the first thing we need to draw is our normal. Now, the normal line is something you won't have seen yet, but it is what we draw. It's an imaginary line and it's what we draw to measure angles with. So the normal line is a dotted line which is drawn at 90 degrees to the surface that you are putting the light on. So in this case, our surface that we're putting the light on is the mirror. So at 90 degrees to that, I'm going to draw a dotted line. And this just helps us compare the angle that the light coming in was at and then the light going away was at. So this is your normal, it's called. Now the interesting thing about reflection is the angle between the incident ray and the normal, and between the reflected ray and the normal. If we look at the angle between the incident ray and the normal, we sometimes notate that as theta I, which is angle I. And then if we have a look between the reflected ray and the normal, that's known as angle R. Now if we look really closely and we take our protractor, what we find is that angle I is equal to angle R. So no matter what angle we put the ray in to the mirror, it will be exactly the same angle as it's reflected, as long as we're looking at the angle between the ray and the normal. So this is known as the law of reflection. So the law of reflection is that the angle of incidence is equal to the angle of reflection. So no matter what angle we put this in, if this was 40 degrees, the angle of incidence, that would mean that the reflected angle would be 40 degrees.